Good afternoon to everybody. My name is De Santi Stefani. I'm the coordinator of the ESC Communities Project, Horizon Europe projects coordinated by APRE, the Italian Agency for the Promotion of European Research, implemented together with ICONS, EURA, and the European Business Innovation Network, ABN. Within the projects, we have co-organized and collaborated with the European Innovation Council, in particular with the program manager Hedi Karray, to the organization of these events on artificial intelligence, and in particular in the context of the Future Tech Week. So today is the second event dedicated to artificial intelligence within the Future Tech Week, and I'm happy to give the floor to Hedi for his introduction, and I wish to everybody a successful meeting today. Thank you very much.
Thank you, Stefania. Hello, everyone. Glad to have you today for this fourth webinar within the series of webinars called Beyond the Hype of AI, what's there in terms of innovation. So would like to throw this series of webinars to dive into the innovation that can happen in AI, what is happening today, what are the limitations of the current AI systems beyond the hype, and then where we are going in the future. So we build those webinars with scientists, with people from startups, innovators from the both, let's say, domains, and also we would like to dive into those domains with contribution from people from social and human sciences, and also from, let's say, VCs and finance, in order also to deal and to understand what is happening in terms of investment in AI. There is a lot of speculation, there is a lot of investment, but how people from the financial domain are looking to the AI innovation. So this is the scope of those series of webinars. Today is the fourth one, and this is a special one because it's dealing with a topic that we are supporting in AIC. So today we have the topic about AI awareness and consciousness. So, and we are happy to have distinguished speakers to go through this topic from different perspective, as I said. So we have Carlos Sierra, Karim Nuira, Anna Tanevska, Flavia Popescu Richardson, Ricardo Sanz, and Luis Lieva. Later we'll give more about their bio and their expertise in the topic. But to go quickly to give the floor to our speakers, just a reminder regarding this topic, how we are dealing with it in the AIC. So it was a call launched in 2021, a challenge at the Pathfinder program of AIC about awareness. It's called Awareness Insight. And 8 projects, let's say, 8 projects awarded for this challenge that compose our portfolio today. So the projects in the portfolio, let's say, tackling different perspectives of the awareness and consciousness from regarding different approaches, but also different applications. So today we'll not go through all the projects. We have some principal investigators from those projects to give to us, let's say, a good idea about what they are developing, their position regarding the topic, and so on. So we'll be happy to hear from the experts in the domain about that topic today. So without spending more of time, I would like to give the floor to Carlos Sierra, who's the director of the Artificial Intelligence Research Institute of the Spanish National Research Council. He's located in Barcelona. He's also a fellow of EURAI, the European Association for Artificial Intelligence. Also, he served as a president from 2020 to 2024. And in recognition of his contributions to the field, he was awarded the ACM CGI Autonomous Agents Research Award in 2019. So Carlos, you have the floor and happy to hear from you.
Thank you very much, Hedi. I hope everybody sees the slides and can hear me. So
Perfectly.
thank you for the invitation. I think this is, and when I was preparing the slides, I realized how challenging is this topic. I mean, we are doing research on it, but it is really very difficult to explain to a large extent. And we are living times in which these concepts are becoming more and more pressuring, I would say. A few weeks back, there was a paper from the University of Southern California where they claimed, after some extensive test, that some LLMs pass the Turing test. So, of course, this is a strong claim. It can be debatable, but we are facing a time in which topics like awareness or consciousness that might have seemed very elusive in the past are gaining protagonism, I would say, in the scientific arena. So our focus on awareness is to develop AI systems that applications are as the trustworthy AI manifesto would like: reliable, robust, explainable, ethically guided, and therefore trustworthy. Especially the last three are the aspects that, at least in our project, we are mostly interested. I put a timer for 50 minutes. So what is value-aware AI, which is what we are interested in, because our approach to ethics in artificial intelligence is to make AI systems aware of our social values. So we say that this is an informal definition, an AI system that is capable of capturing human value system, understanding that value system, abiding by it, and explaining its behavior and that of others in terms of that value system. This is something that any human can do, but for an artificial system, it is quite difficult. I mean, let me just, okay. So what could value-aware AI achieve? If we manage to build such systems, what could we achieve? Things like monitorized value compliance, whether a particular system is complying with the values that we set the system to abide by. Sorry, I have some. It can give advice on courses of action aligned with these target values that you are interested in the system. Certify, and this is a very important aspect nowadays, that the process or a system complies with those values, and help decision-making processes that aim at following those particular values. So having a value-aware AI system could be a very important and meaningful way to achieve the ethics that we want for AI systems. Now, from that informal definition, I mean, how can we do, because my background is the background of an engineer, how can we define some notion of computational awareness? It took us a long discussion in order to define what does it mean that the system is aware of something, aware of X, whatever that X is, in a given context, C. So we say that a system, and we take here Turing's approach, we define what awareness is. We say a system is aware of X in a context C if we can observe a number of things. First, that the system has access to a representation of X in that context C, that this representation is coherent, that means without unresolved ambiguities, and that this representation is expressible in human understandable way. So through language, for instance. So this means we can represent the concept we want to be aware of, that is coherent in that particular context without these ambiguities or contradictions, and that it can talk to us about that particular value, concept, sorry. Of course, we are interested in systems that are aware of a certain value. So we need to say what value awareness is. Awareness of a value B for us is based on the representation of the value, taking into account two elements. First, a preference over a state of the world. A value, in a sense, is telling whether a state is preferable over another, and that is what can drive a system to take decisions. And the second element is that the system contains norms that are aligned with the preference that we define for that particular value. And that those norms determine, prescribe, and express what is the correct behavior. So in a sense, they provide a moral stance. And this is the key issue that we can, and I'm sure we will discuss during today. So there is a triangle between values, which are these preferences over the states of the world that we can represent, norms that are basically the institutional element that determines what is the right behavior of a particular entity with respect to those preferences, and finally the behavior that actually a particular system shows. So in a sense, what we are saying here is that we relate awareness to the notion of expressible alignment between norms and values and preferences. Well, this is what would allow us to say that a particular system has a moral stance. So a system that is aware of values, we can say that it is the path to have a moral stance. What does it mean to have a moral standing? Well, this is not an easy concept. The idea, this is a paper that digs a bit on this concept, is that an entity has moral standing if itself or its interest matter intrinsically, at least to some degree, in the moral assessment of actions and events. So if we do a particular action that affects our environment, any entity around it will have a moral standing if we are affecting the interest of that particular entity. Well, how can we define certain criteria to determine whether an entity has moral stance? The classical concepts are sentience, which is a capacity to have positive or negative experiences. This is often associated to living creatures, okay? So any entity that can distinguish or can analyze an experience as being positive or negative, we could determine it is a sentient being. Or a bit more general, the notion of consciousness is just the state of having an experience. So it doesn't necessarily require sentience. It's the fact that it can have an experience in a particular context. So possibly what can happen, and probably this is debatable, that AI could possibly be conscious, but not necessarily sentient. And this is related to an experiment I will show you immediately. Well, first of all is the fact that animals are recognized as sentient beings is the element in certain laws that are being passed in different countries. One of the examples is the law passed in the UK about animals recognized having certain rights because they are sentient beings. And particularly interesting was that after that, things like octopuses were considered as sentient beings, which means that they are somehow subject of certain rights. This is an interesting approach. But going back to the notion of sentience and consciousness, I mean, there is Chalmers' typical trolley thing, in which you have two options. You have a person that is sentient, and then you have a number of non-sentient beings, zombies. This is the zombie experiment. So what should you do to kill the sentient being or kill an indefinite number of non-sentient beings or zombies? This is a matter that, he would answer that we should save the sentient being and eliminate the non-sentient ones. But still, there are many discussions, and even Chalmers himself puts that into doubt when you have a very large number of non-sentient beings. So this is a matter of discussion. What is clear also is that the labeling of an entity as being conscious is a judgment that we humans do. It's something very difficult to intrinsically obtain from others, okay? Again, we will possibly discuss this later in more detail. So there are other criteria that people use to assign the concept of moral stance to an entity. It could be the idea of cognition, so the capacities that an entity shows as agency or rationality, for instance. People associate moral stance to living entities. So a living entity qualify for moral standing, maybe only whether you can assign the idea of a qualia, of a subjective experience, subjective experiencing the environment. Others would define them as those that are capable of social relationships, such as care or behavior. This is a much more closer to what we do in artificial intelligence. So an entity will have moral standing. It is roughly, in a performative way, is roughly equivalent to, sorry, to an entity with moral standing. So we have an entity that is artificial, but it is the behavior is close, or you cannot distinguish with an entity that has moral standing than it will have. That's why things like the Turing test are so relevant in this discussion in order to assign moral stance. Because if an entity has moral stance, then we're in muddy waters here. Okay, why value awareness is useful? And well, it can, as I think you mentioned this a bit, I mean, it can advise on a course of action to a human compatible with certain given values and associated norms. I mean, this is very important for us. What should we do that respect our values? It can also monitor the compliance to norms and values. This supports certification. If we, after the AI Act law, in which we will need to certify the behavior of our systems, I mean, having the capacity of certify that a certain system will comply with norms and values is extremely important. Also, it can identify and learn the values and norms implicitly used by a human group. So using machine learning mechanisms in order to learn the normative behaviors, or actually the values, which are the preferences, these positive and negative experiences of sentient beings that we were saying from the interaction with a human group. So these elements, together with the idea that at some point we will have autonomous systems that will perform actions that are compatible with those values, are extremely important in the system we're going to build in the near future. Okay, so checking value awareness is a key element. What has been our strategy? Well, we have proposed a computational architecture and developed a toolbox that allows developers to basically build AI applications that are value aware and embed them with human values and align norms. Okay, so we build the application and we managed to put inside the architecture the elements that would guarantee that the decisions made will be value aware, will be inspired by the values. And we are using the toolbox in 3 domains, which is social media, trying to counterattack the, let's say, the misinformation problems. Social robots, we were saying entities that can care about others, social relationships. So this is one of the areas we want to apply it in. And social decision making, which is in medical protocols, supporting doctors in their decisions. How is this architecture organized? It is organized following this architecture based on the global neuronal workspace. Basically, this system, this is a, I would say, psychological approach, in which this is also a problem in this area, that we have psychological approaches, philosophical approaches, neuroscientific approaches, and engineering approaches. It's very difficult to put everybody on agreement. Here, the idea is that the perceptual contents that are obtained by localized processors like our sensors, I mean, only become conscious when they are widely broadcasted to other processors across the brain. So if we take that as a metaphor for the architecture, what we developed in the project is an architecture where you have C0 level, which is all those components that do information extraction from the context, from the environment. C1 components that do the information integration, that are those elements that are activated by this broadcasting of information from C0. And then a reflective element, C2, that basically takes the information from C1 and C0 and modifies C1 and C0. So there is a kind of an internal reflection that makes the system adapt to those values in order to guarantee that the actions made by C1 and then transmitted into C0 are aligned with the values. So this is the approach in which we have these 3 layers. I mean, I mentioned the one concerned with information extraction, the one for integration and analysis of the information, and then the reflective layer doing the value alignment of the behavior. These components are independent in any layer and then can be integrated dynamically. So the idea is to have an architecture where you can add and remove systems components very easily. I mean, you can have, for instance, C0 components like a sensor in which you have certain percepts, certain parameters that determine the behavior of this sensor. Similarly, for an actuator, components at level C1 in which they are interacting with other elements of C0, C1, C2. These are at the center of the architecture, contacting with C0 and contacting with C2. C2 basically interacting with C1 and C2, and then interacting with the levels below. And I should stop in a couple of minutes, oh my goodness. So basically, what that allows you is to build up an architecture like this one, in which you have the different components and then the influences that the components have in a data flow. That's how data flows. And also a control flow component at the part of the architecture at the same time that will determine who modifies whom. So what parameters are modified, what norms are modified, or even what the topology of the architecture in a particular moment can be. So all this dynamicity allows for all these complex combination of components that will show that awareness that we are interested in. I don't have time to go more than, so we have developed a number of components, C0, C1, C2 components with the different project users, and we have applied that to, and I will finish with these two slides. Social media is basically protecting individuals from malicious media content and information distribution bad practices. Social robots ensure the behavior is within moral bounds and respects the values of those humans interacting with the social robot. And in decision-making, support the formulation and action sharing of medical protocols by assisting doctors in their decision-making for explanation. I will not go into details with this, there is no time, but basically to conclude, we believe is an engineering path to achieve ethical and trustworthy AI, value awareness. The definition is controversial, and we will probably see different views during today. We consider, however, awareness as a necessary requirement for moral stance. The architecture implements these ideas that our definition, our computational definition of awareness, and we consider that the architecture, for us at least, is a key element to achieve that. Initial results with humans show that the users really commend the approach in the different applications we have made for social media, for robotics, that we have been doing field studies with patients in hospitals, but also with doctors in hospitals in their decision-making tasks. And I will stop here. I talk already too much. Thank you.
Great presentation. Thank you, Carlos. The floor is open. If there is one or two questions from the audience, you can also use the chat. I don't know if there is any question, please raise hand or put it in the chat. Also, if it comes later also, it's possible to put in the chat and Carlos can go through and answer.
Yes, if there are questions in the chat, I can answer them along the way, yes.
Okay, right. But I have one.
Good.
From my side. You know, when we talk about AI systems, we talk about building capabilities to process information. So, like, you know, there is a capability to learn of the AI system. There is the capability to make reasoning capability. So we'll talk about capabilities and abilities, and those are inspired from the human intelligence capabilities. So awareness, consciousness are abilities of humans' minds. But usually when we build AI systems, we are based on mathematics. So we are developing algorithms doing that. So what kind of algorithms, mathematics, approaches we can use to build such capabilities for an AI system?
Well, first of all, I mean, you are going in the tradition of, in one of the slides I mentioned, I mean, there are aspects like the cognitive approach in which you say that the moral stance can only be a property of cognitive entities. So entities that have some of the properties that you mentioned, right? Or in a sense, also connects to behaviorism in the sense that any system that behaves in an indistinguishable way to what a human does can be considered an entity with a moral stance, and then maybe the subject of right or all that. I agree. I mean, the systems are run on algorithms, but never mind. I mean, if those algorithms show the cognitive capability, I mean, we don't need to be restrained by the fact that maybe the human way of learning is different in order to assign the capability of learning or the capability of reasoning. So I don't think, because otherwise the conclusion would be that only humans can be considered sentient beings, or can be considered like subjects of awareness or consciousness. And that will be an anthropocentric approach to the problem. Some people may follow that, but in general, we as engineers, we prefer to be able to define properties, measure those properties, and then assign concrete definitions. So I would say, yes, we're developing algorithms, but there is nothing against a system with those algorithms showing the properties that would call that the system is aware of something.
Wonderful. Thank you very much, Carlos.
No worries.
So let's move to the second presentation today. I'm happy to introduce Karim Nuira, who's here in the room with me today. Karim is a serial tech entrepreneur. Previously co-founded the G-Rocket, acquired by Oracle, and he's also the founder of Super Intelligence Computing Systems, is a company funded, awarded by AIC, and trying to develop, let's say, an artificial intelligence towards AGI, as he's presenting the company, and also especially to revolutionize industrial automation. So, Karim, the floor is yours. Please go ahead.
Yeah, thank you very much, Hedi. Very happy to be here, and very grateful and proud to be awarded the PSC grant, and we look forward to work together. So I'm the founder of this company, Super Intelligence Computing Systems, and I'll explore how we can be inspired by China to be the next best AI.
To give you context, 72% of all industry assembly today is manual, and 80% of all warehouses have no automation. This is because today's automation is not flexible enough to solve this, to automate these environments. There are 80 million industry workers, so there's an automation potential corresponding to trillions of euros. The business case to automate is fantastic. A robot working 24/7, 4 times the human speed, corresponds to 16 FTEs, 60 full-time employees. So there's a fantastic business case for the client, and there's a huge market. And still, this market is this opportunity is not reached. And the reason is the environment, assembly environment, and also warehouse environment are extremely complex environments. Unstructured, unpredictable, with high variability. And it's a huge challenge to automate. Traditional robotics is inefficient. Program robots are very robust, extremely scalable. You can move one robot from Sweden to Japan, we still work with the same program, but the flexibility is virtually zero. So if you change the orientation of the goods, you need to, in the best case, recalibrate the robot. In the worst case, you need to reprogram the robot. You can add AI to add flexibility. And today's AI does that to some extent, but today's AI is not robust. You can call it, it hallucinates, it's not robust, it's not stable, and it's also not a scalable solution. In order to make AI work today, which we have solutions today taking place, you need to add a lot of legacy code. So you pair AI together with program to set up guardrails to make it stable and handle special cases and so forth. And the training is very inefficient. The AI doesn't learn anything on the job. It needs to be pre-programmed, pre-trained in batches, and this is not scalable and demands lots of resources in terms of data and compute. So we have developed a new type of AI that is flexible without compromising robustness and scalable. And flexible, we can translate that to more intelligent, and I'll dive into that. So what we have aimed at is to solve the hardest problem in AI, and that's real-world AI. So AI acting in the real world, interacting within its environment. And in our view, and many other researchers agree with that, this is most probably the fastest way to superintelligence, and I'll explain you why. If you look at the valuation of companies, working towards AGI or superintelligence. They have super high evaluations in the United States. And this is because this race towards AGI is very interesting and very valuable, very profitable. Goetzel, a scientist, he suggests that AGI can be reached by 2030, or even as early in 2027. And actually, our company's objective is to reach AGI in 18 to 24 months. So this is actually something that's reasonably realistic and doable. So how can a small Swedish team, we're about 10 people today, beat Silicon Valley big tech? First of all, we've done it before, actually twice. Once with JRocket, which is a Java virtual machine, today a part of Oracle's product portfolio. It runs on 20 million servers worldwide and is a de facto standard for Linux. And also our team has, Per in our team was co-founder of MySQL, also a company acquired by Oracle, and this open source database runs on 150,000 companies worldwide. And there's also evidence in several studies that a small team can actually be very efficient if it has right team members. So we have an all-star team of some of the best development engineers in Sweden. And this is a quote from Joshua Bengio, Turing Prize laureate, who said that actually there's a good opportunity for a small team to do important work in next generation AI without the large compute that the large companies have. And I'll explain why this is possible so later. First of all, in order to build intelligence, you have to know what intelligence is, or at least how can you measure intelligence? Is it possible to measure? You can have something like the Turing test, IQ test, university exams. None of these apply to dogs. And dogs are considered intelligent by most people. So this is another way of looking at it. If you look at if you exclude dogs for a while and just look at the achievements. This is by now an old picture. I got it from Max Tegmark's book. The water level shows what conquest AI has done so far, and the hills above the water are still open to conquer. But this picture is a few years old, and we can see that already social interaction, programming are touching the water nowadays. But probably science and research in theoretical physics would be still a challenge, and mathematical proof theorem. So scientific research would be far away. But we see already today children's books written by AI and so forth. So we really have a very rapid approach and also rapid development. This is another way of viewing AI development. So today we have conversational AI. We have large language model that can handle language produced by humans, and by recombining these with statistical rules, you can simulate intelligence. What the companies are working with right now is a reasoning AI. So this is work in progress. It's difficult to achieve this with large language models, and I'll explain later why. In our project, we are aiming at a reasoning AI that can do complex reasoning in many steps in a stable way, in a robust way. And then we also aim at a more autonomous AI that don't need a human in the loop. So in this scale, 2 or 3, we would deliver in 18 to 24 months. We're not alone to regard large language models as a dead end. This is a quote from Jan LeCun, Meta chief scientist and also Turing Award winner, together with Geoffrey Hinton and Joshua Bengio. So you need basically a new engineering paradigm to reach superintelligence. Necessary condition for AI, for superintelligence, is hardware. And actually today, this is not the bottleneck anymore. So the computers are today on par with the brain. So if you compare the brain with today's state-of-the-art technology, in terms of storage, we have the extra drive, the hard drive from NVIDIA. which has 0.1 petabyte, and the brain has approximately, according to Kurzweil, 2 petabytes. So it's on the same order of magnitude. The same goes for number of computing units, where NVIDIA chip has 200 billion transistors, and we have about 100 billion neurons in the brain. Of course, the neurons are much more sophisticated than transistors, but slower. And we can see that in the number of compute per second, exaflops, petaflops. So this is not the bottleneck. The bottleneck lies in the software. We don't have the right software. Large language models are not the right software for superintelligence. So in order to build intelligence, you have to understand what intelligence actually is. Best definition is something that makes it possible to adapt to changes. The ability to reach the same goals by different means. So adaptivity is important, adapting to changes. And this is relating to survival. Intelligence is a feature of nature that we have discovered or experienced, and it's about survival. And survival, at its core, is finding food, escape predators, and finding a partner. So these basic survival skills have one capability in common, and that is navigation. In order to find food, you need to be able to navigate. In order to find a partner, the same, and also when you have a lion. And if you think about navigation, at its core, it's about reasoning, planning, prediction, and simulation. But this is actually basic intelligence. If you have solved the basic problem of navigation, you have also solved the basic problem of intelligence. And what's the necessary condition in order to navigate? You need a map. We humans, we have a mental map of the world describing objects, relation between objects, basic physics like gravity, low inertia, dynamics. And this is what we use in order to adapt to the environment and make decisions. So a word model is a necessary condition for intelligence. If you don't have a word model, it's very difficult to navigate and act intelligently. This is a missing link in today's AI. Today's AI has no word model. It's an implicit mathematical model which describes a word, but lots of the structure of the information is lost in this mathematical description. And it's not really grounded in the real world. There's no interaction with the real world. It's merely a bit naive parroting, but you can get in this sort of the idea. And this is also the root cause for hallucinations and the lack of robustness, since the structure is lacking. And the basic principle or strategy in today's AI is a brute force strategy. Large computers, large models with many parameters, billions of parameters, and large data sets. And with large enough model, the hope is that you can capture enough information to make the model simulate intelligence in a fairly robust way. But when you are at the fringes of the model, anything can happen. So this is not a robust and sustainable way of doing things. And it's not scalable. It needs a lot of data, and it's an explosion in resources. So in terms of also the learning principle behind the models, reinforcement learning, it's a brute force search strategy. Basically, like a monkey. If you put a monkey in front of a typewriter and wait a billion years with the hope that it would finally produce Shakespeare collected works, it doesn't mean that it has a talent for it. It's just brute force search strategy, and no real learning behind it. And also it's not an on-the-job learning; it's a batch learning. So you don't learn from interaction with your environment, from feedback. So it's a very rigid way of learning thing, a very inefficient way. So is super intelligent possible? Well, the human brain is an existential proof that we can be intelligent. So and you can actually describe and define what intelligence is, and if you can describe it, you can also build it. So a paradox is in order to learn, you need to know in advance. And this is a bit tricky. How can you start learning without knowing anything? So you have to seed the model with something. So we humans, we're born with 700 megabytes information in our DNA. And this is sort of enough to seed a building of an internal word model, which we start with as babies. And back to the title of the speech, we need to find a way of learning a word like a child from the very beginning. We can't start with Shakespeare's collected works and all the information internet. We need to start learning about the word. We need to create a word model. And basic to the word model is, as was mentioned in the last speech, you need some sort of representation, a way of representing the information in the word in an efficient way. And this is present in the brain. So we take inspiration from that. And about awareness, self-awareness, and consciousness, a word model contains the objects in the world, but it must also contain the robot or the AI itself. So an AI, in order to make an AI super intelligent, you need to have an embodiment, you need to have a robot interacting with the world. And in that context, the AI need to build a model of itself. If it has a model of itself and its word model, it is actually self-aware. So self-awareness comes together with modeling the world. If you call that consciousness, that's more a philosophical question, but self-awareness would be essential from the very start. So you need a word model, and in order to interact with the world, you must have some sort of learning that's continual, at least. Ideally, it's online and in real time, but it must be continual and not batch-based. And the system has the possibility to interact, get feedback, and learn from feedback continually. So how do you build this type of machine? What's the blueprint for next generation AI? Well, actually, the brain is a very good source of inspiration. And intuitively, you can understand that if you have a complicated problem that you need to solve, you need a complex machine in order to solve it. One example is from the World War II, where the Germans constructed Enigma, a fantastic machine which coded the messages in a way that no human was able to crack it. And Turing, he said that, well, if we have a machine that creates the code, we most probably need a machine to crack the code. And they built this computer and succeeded in that effort. So we can say that today's AI does not have enough complexity to be able to be super intelligent. If we look into the brain and compare it with today's AI, and also you can get a hint about how our model works. So, for example, today's AI is a large monolithic network, while the brain actually is modular in its architecture. The neocortex, the shell of the brain, contains all the neurons, and the inside of the brain is actually connections between the neurons. And neuroscientists found out that the neocortex is actually modular and consists of cortical columns, size of rice grain, 150,000 to 200,000 of them. Exactly how large they are is a bit debated, but there's some sort of modularity in the architecture, and this is very efficient. It makes it easy for nature to develop successively larger brains. These cortical columns, they work as the brain's microcircuits, and they are sort of independent and general. So their function is dependent on their input. So if they are wired to vision, they process vision information and so forth. So this modular architecture is interesting, and something that we are using in our system. Next, information flow. In today's large language models, the information flow is one way, feed forward. There's very limited loops. There's there's loops introduced in this type of architecture right now, but there's really no long-term update of the long-term memory update, no dynamic long-term memory. While in the brain you have feed forward, you have feedback, you have much richer information flow. This makes the brain more powerful, and this is also part of our architecture. We have a recurrent network. And this is shows one of our first demos from 2022 when we demonstrated online learning. So close to continual learning, we have the game Pong, and this system learns how to play Pong without any instruction, and not by reinforcement learning, by actually trying to play. And you can see the red squares is the attention of the system. And at the start was the whole square was red, but now it has identified interesting features, and following this with the attention. And on the right screen you can see this is like the inside what the system has learned so far, and it can communicate to us and tell us. So it's a way of having a explainability and a visual interface to humans, and explain what it has learned. And here you can also add the high-level instructions. So now the system has learned to hit the ball, but you can actually change behavior and tell the system to not hit the ball, and it changes its behavior directly. So this is here we demonstrated this type of recurrent network that we today implementing in robots, and also online learning. So, and this is our basic assumption, that you have to learn things in the right order, and the right order is the same order as children learns. So children, they don't start with learning language, they start with learning the word, they start to learn objects, they start to learn gravity, and so forth. So this is the same learning path that we use in our system. And the thing is, with structure, the structure itself makes the system, or the more efficient, the representation, the structure makes the system more compact. If it's more compact, it doesn't need the same amount of compute. With structure also comes robustness, and with structure also comes explainability. And with structure, it's easy to use language. You just add language to the structure, and you then have language that actually is grounded in the real world. That's semantic grounding. So we start learning objects, we start learning physics, and then we add language on top of that. And later, more advanced cognitive functions, problem solving. So we are actually mirroring the development of a child. The easiest robot task that we're working with, starting with, is pick and place, moving an object from A to B. At its foundation, it's a navigation problem. To moving something, identifying something, that's about navigation. It doesn't matter if you move the robot or if you move the robot hand. So this is the first step. The next step will be using two hands and do some sort of industry assembly work, and then move to further more and more complex tasks. And the thing is, the most challenging to build is the first toddler years. If you have the structure right and the system right and the model right, this development towards an adult capability will accelerate, and beyond that to superintelligence. So this is just to show also current state. We have a first version of our AI robot brain doing pick and place. This is from the Automatica fair in Munich, where we just after a few months we excelled in this field, and we are probably one of the best in pick and place in the world. Even without the full system compared to current state, that doesn't mean that that the problem is solved. It's a very complex problem. So here we can call this 2D picking, because the objects are presented in bins, and it's easy to see the objects. If you stack the objects in a pile, it's very difficult to solve the picking. And if you have irregular objects like polybags that we will address in this EU project, it's really tough. So, but even with a very rudimentary implementation of our system, this is from 2023, we managed to very good performance. So this is the pilot customer we work with right now that we continue to work with in the C project, No Waste Logistics, part of the Dole Group. And about some final words about robotics. Humanoids is an excellent, I spoke with Hedi yesterday, is an excellent brownfield solution if you have an environment which work environment where humans work. It's plug and play, replacing the human with a human or robot. But in a greenfield solution, a general purpose robot would probably look very different. You don't need a head. Probably wheels are more efficient than legs. The similarity is 2 arms is most probably efficient because you need one arm to hold the goods and other to work with it. Usually, cameras are extremely efficient when you put them on the arm instead of the overhead in many applications. So this is most probably what a general purpose robot would look like. And actually, we already have this type of hardware. Humanoid robots is in development, but there is already today mobile robots that can do advanced manipulation. You can actually put, this is from KUKA. We aim to work with KUKA robots in this, also one of these projects. And this is an AMR, so a mobile robot with a cobot arm. You can put 2 arms on it if you want, and then you have a mobility, you have dexterity, and you can put any type of sensors, LiDAR, cameras, and so forth. So, yeah.
Thank you, Karim, for the presentation and tackling that that aspect regarding also AGI and the link with the self-awareness and so on. I see that there is some discussion in the chat regarding the world model, and because you have mentioned that current AI haven't world model, but if I would understand what you mean, that current AI is not building its own word model, right?
Yeah, it has a word model, it has a mathematical representation of a word, but it's implicit. And a lot of the structure of the word is lost in that type of mathematical model.
Mm-hmm.
So if you have this trillion parameter model, it's not clear what's the significance of knob number 14 compared to knob number 2,245. So they are big black boxes.
Mm-hmm. Okay, I will let you also exchange more with in the chat about that topic. But before going, also, I would like also to talk about the hype regarding the speculation about AGI. Firstly, the problem regarding no consensus regarding AGI definition. This is the first thing, and how this like word model approach help robots to learn more effectively and being self-aware.
Yeah. So there's always a hype with AI and AGI, and our definition of AGI is complex reasoning in many steps in a robust way, and this. So, what do you mean by complex? Where even basic reasoning in many steps is difficult. So this is what we aim to achieve, and also have the autonomy of the system. So those two combined is our definition of AGI. And then you can, well, what is the level of superintelligence and AGI and so forth? We know about the intelligence of a dog, of a human, and superhuman, very intelligent human, and then there's no limit about that. There's superintelligence and superintelligence. But with this type of architecture that we're creating, we can follow that path from a baby to an adult and to superintelligence and beyond.
That's great. Is there any other question from the audience? Can take it, or better to have it in the chat. And now we move to another topic related to awareness and consciousness, which is very important regarding the ethics and the responsibility regarding development of such AI systems. And for that, we have a very nice speaker from University of Uppsala University, Dr. Anna Tanevska. Anna is a postdoctoral researcher, and she's part of the AIC Pathfinder project SIMAware. So Anna, please go ahead.
Thank you. Let me know in case you have any issues with the audio, but I mean, we did the
Everything
check,
is
so,
perfect.
Good. I'll just quickly hide maybe the controls. That should be fine. So thank you for the invitation. My talk will be maybe a little bit less technical and more looking into the legislation around, bringing ethical and trustworthy AI. And I will do a short case study on what we are doing at Uppsala University under SIMAware. So at the beginning, we had a nice overview of the projects in the EAC Pathfinder call. SIMAware is one of the 8 projects that is working on artificial awareness. Specifically, we are at creating a framework for situational awareness in mixed autonomy. And we are looking at applications with autonomous vehicles and with multi-drone systems. So this is, as you can imagine, a very complex scenario. We are trying to understand how to bridge the gap between having a very dynamically changing environment and having a framework that can account for that, so that we can calculate the risk of every action that an AV or a drone would like to take, and calculate all of the uncertainties that are present. So the big question here in the project that SIMAware is trying to understand is how to guarantee safety and resilience while building this kind of framework for artificial awareness. I'm keeping the talk at a relatively general level, but for any more in-depth questions that you may have, or questions regarding some of the studies, you can write in the chat, and then I can maybe give more information so that we don't go too much over time. So we are starting with this problem, designing an architecture for artificial awareness that would support mixed autonomy, so being able to have both autonomous interaction from the vehicles and drones, but also being supported by humans. And then where we are coming from in Uppsala is in the next part, which is that these artificial agents, regardless of the fact that they may have high autonomy, they still will interact with human. So they will interact, if it's an AV, so autonomous vehicle, it will interact maybe with the driver that is in the car, with a passenger, with the pedestrians that are crossing. Multi-drone systems have usually drone operators, and they're there as well. We need to have a communication. And so all of these interactions need to be accounted for in our architecture. And this is a very complex problem. What we are trying to understand is if and how we can model the different kind of human partners or human peers in our architecture, which depends from one interaction scenario to another, but then also look into this, my topic, which is how to guarantee that this interaction will be ethical and trustworthy. So what we would like ideally is to foster trust and foster transparency between the agent and between the human. And this is a very complex issue. We were talking so far a lot about what AI can solve. And here, if you go back to the image that Karin presented, we are definitely not there. So AI, when asked to generate an image, let's say, of what trustworthy interaction looks like, we have this, which on first gap, maybe it's interesting, on the second, it's very nonsensical. And even though it's definitely a complex scenario with vehicles, there is no shed of trustworthy aspect into it. So these are high-level concepts that we need to tackle from another side. So leaving the AI behind and going actually a little bit more into the legislation side of it and looking at what are the existing guidelines that can help us. So I'm not saying anything new here, so I will not focus so much, but where we are working as well is from the Altai guidelines. So looking at the EU guidelines on trustworthy AI. We have been working a lot with this in our research. For reference, these are the 7 here. So we are talking about human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, and fairness, well-being, both societal and environmental, and accountability. And these 7 principles are to be constantly revised during the life cycle of any kind of AI product. And by extension, an architecture for artificial awareness falls under this category. These all involve different issues. What we are at Uppsala within CIMA we're most interested with are the following 3. So looking at the topic of human agency and oversight, looking at the topic of transparency, and then doing both of these research questions under, or let's say on top of groundwork from diversity, non-discrimination, and fairness. For us, what that means is that we are trying to actively co-design studies. So when we are working with participants, we try to work with them to have participatory design studies where we are talking with the stakeholders, which for us are the potential users of a system, throughout all stages. And in that way, try to be very inclusive and try to be fair when designing a new study or a new system. In our work, to translate that to more concrete examples, this is the architecture. I mean, it's one version of the architecture at CIMAware, where you can see how the situational awareness is represented in an agent as factors of information that the agent gets from the environment, from another agent that communicates back, and how it uses its own knowledge. And where we are focused in Uppsala is actually the part where the human comes into play. So we want to understand how we can foster this kind of trustworthy communication with the human agent. And specifically, because we are interested in exploring transparency, oversight, and agency, we have the following 3 research questions that guide us in our work, which is understanding to what extent should the agent act autonomously. And this is a big one, especially in the field of autonomous vehicles, where the technical goal is to have the higher level of autonomy possible. But we are also trying to understand how this correlates with the wishes of the human. The other one is more connected to transparency. So how can the human users be in the loop and monitor the interaction and understand what is happening? And then how can the agent, so in our case, the autonomous vehicle, support the users without at the same time replacing them in a negative connotation? So how can it provide the best possible support while still allowing the users to have a full sense of agency? We are conducting studies with human participants, and we are trying to then use this data to basically model communication interface in our framework, or actually create a computational model of the human itself that can be plugged into the framework. And we'll talk briefly about the big studies that we have done, which is several smaller works on transparency, agency, and oversight in driver-AV interaction. So, as I mentioned already, our approach is very user-centered and very participatory. So we have started doing workshops first in smaller groups to understand what are the main issues that we should focus on, and then we've moved to a larger scale study. Our first workshop at the beginning of the project was a very hands-on workshop with a smaller group of about 15 participants, divided in smaller groups of between 2 and 4 people. We were trying to understand what kind of communication interface they would like to have with the AV. So given all of the information that a car that operates within our architecture for awareness has, what is the information that users want to see when they are in a day-to-day life and would be interacting with this car? And also the other big thing, and here I will just stress the abbreviation because you will see it a lot in the rest of the slides, is the levels of autonomy. So what are the different levels of autonomy that the users are most comfortable with? After we did the first participatory workshop, we then moved to a larger scale online study where we used as a baseline the 2 communications interfaces that we got from the participatory workshop, which I will show in a bit. And then we tried to manipulate the level of information provided to the participants and see how that affects them. So how it affects how trustworthy they find the system and how it affects their level of agency. So how much they would like to be in control or how much they would give autonomy to the car. And finally, the current ongoing work, so I don't have a lot of interesting results from that one, but I will just mention it, is then working with this data to create a mathematical model of the human driver, which can then be added into our infrastructure to help when the situational awareness is making new decisions. The workshop on levels of autonomy and communication, we had 2 different scenarios, and these were granted from the literature, where the scenarios of a car on the highway, on a busy highway, and a car driving in suburban streets are very common environments. So we had these 2 use case scenarios, and we had an unpredictable moment or a risk moment in both of them. In the highway one, it was when another car would merge at a very high speed, unexpectedly. And in the suburbs one was that when the car would suddenly start slowing down without any visible obstacle, so without a child or an animal crossing, but because the knowledge awareness of the system has detected that there is an upcoming school, and so the traffic rule changes to lower the speed. In the workshop, by the way, this was very hands-on with flip charts, so they would have images printed out, and we would draw. So which is why you see here images and not any kind of simulation. We are currently working with simulation with some of our industry partners, but so far this was all image and text-based. The 2 activities we did, one was modulating the level of autonomy. So we worked here with the SAEs, so the global standard for autonomy in autonomous vehicles. We worked specifically with the levels between 0 and 3. There are in total 6 levels, so going up to 5, where it's human optional. And they vary by the levels of attention that the human can remove. So level 0 is human is a driver in the car, and there is almost no assistance provided. Level 1, for instance, is assistance for the braking or for the speed. Level 2 is partially automated, so you don't need to have your hands on the wheel. And level 3 is eyes off, but not really mind off. So you can remove your eyes from the dashboard for a moment. You can maybe do some other task, but you need to be present in the car and to be ready to take over. And these are the levels that you have when you currently have a commercially available AV. So levels 4 and 5, where you are a passenger and you may take over or not, are available in a research capacity or in a geofenced capacity in the world. So in various places in the US, China, and Japan, you have robot taxis, but they are either very, very limited areas that are very well mapped, or there are operators. So they don't fit this kind of standard for autonomy. So we worked with levels 0 to 3, and we narrated each scene from the 2 scenarios to the participants and asked them in which of the scenes, what is the level of autonomy they're comfortable with. And then the other part was connected to the transparency issue in trustworthy AI, so understanding how much information users want. We tried to co-design a communication interface, so understanding what the dashboard of this ideal AV would look like for them. We presented all of the situational awareness information the car is processing, and you can see here that is information about the state of the car or the environment or the actions, and then worked with the participants to design the interfaces. From the workshop, we saw that how people behaved towards the AV, so whether they felt positive or negative at the thought of interacting with an autonomous car and the level of autonomy they selected was not correlated at all with their own driving experience and behavior. So whether people had more risky driving behavior or more careful one wouldn't be an indicator of then how they feel about an AV. We saw that if they have positive attitudes towards AVs, they tended to assign a higher level of autonomy, which is a very intuitive result. But even though we were in such a small workshop group, we still saw this kind of weak correlation. And finally, during the participatory design workshop, we found a sex effect for the level of autonomy, whereby it depended on the environment. So we saw in the workshop that female participants tended to have a lower level of autonomy in the suburb scene. And because this was participatory design, so we talked a lot, this was explained as they felt that the risk of having suddenly a child, even though it's not visible in the scene, or an animal jump out, is much higher than the risk of being on a highway where every car is a consenting participant in traffic. But this was something that we were curious to explore, and spoiler alert, doesn't carry through. Actually, this was just a result of the people that were in our workshop. And in our follow-up study, we didn't have the same effect, even though we had much more participants. And then we designed the two interfaces. So these were the two main interfaces that people wanted. Either a very, very complete communication interface that could show at any moment all of the information the car is processing, which was done in order to feel safe and to feel that the car is trustworthy and reliable. So they would like to know how the car is processing information. And then the other one was a very minimal communication interface, where they wanted basically what you have in modern cars with the GPS navigator, seeing maybe the speed and acceleration, but not really seeing any of the other computation that goes in the background. So they wanted to be notified in case of an emergency, but not to have it constantly present. So we took these two different interfaces, the complete and the minimal. We translated that to a high information and low information level for transparency, and then we ran a follow-up study. In the follow-up study, we had, again, the same two scenarios, and we had more like Dungeons and Dragons style narration of each scene and what happens in it, and asking participants to select an option for what they do and describe how they feel afterwards. Here is an example. This is from the draft. So in the parentheses, you can see the level of autonomy, but these were not part of the actual study, so that they just had the description of the actions. Yeah, it was a 2x2 between subject design. So the level of information was what we manipulated, and the order, whether participants had first the highway or first the suburb one. In total, we had 200 participants, and here's a bit more of their info. And then we started analyzing this data to see what we could find. So as with the workshop, again, driving experience was no indicator at all towards how people would behave towards the AV, how much they would trust it, or what would be the level of autonomy. So we found, again, a positive correlation between how they felt about AVs. So having, before starting the experiment, already a positive attitude towards AVs in general meant that they would have, during the experiment, higher rankings of the level of autonomy and the trust. Trust and autonomy as well are correlated in an interesting way. And I'm wrapping up. I'm aware that I'm at a 15-minute risk, where trust was more intrinsic to participants. So if they had a higher trust rating in the highway scenario, probably also in the suburbs they would have as well, even though they would vary between them, but it would still be a more intrinsic value. What we found with the level of autonomy was that it depended solely and entirely on the environment. The highway environment gave much lower level of autonomy, the suburbs gave a higher one. And it didn't seem to be correlated with anything else. The different information levels did not impact the level of autonomy, but they impacted the trust in the participants. So transparency is really important for trustworthy AI. The higher information level had more ranking of trust. And for the sex effect as well, there was no correlation between the level of autonomy, despite our findings from the workshop, but the trust was lower in female drivers. And that was an interesting finding. So it slightly correlates with some of the things from before. And finally, the current ongoing work is using this data to create a mathematical computational model of the human driver. We are trying to do basically a set of transition probabilities to see how people behave when they have higher level of autonomy or lower, and when they, let's say, change between them, and understand if this depends solely on the environment, or if when we look into the nitty-gritty of it and look at the smaller transitions, if we get very different values for participant sex or for the level of information. So I will wrap up here and then take any questions. So thank you.
Thank you, Anna. Thank you for the presentation. I don't know if there is any question in the chat. I don't see. So maybe if there is any question, so you can go through the chat. But I have, one question regarding the use case, because I personally,
sorry, share again.
I had this experience to be in this like autonomous car in US, and as a first impression, it was amazing. As a user, it was amazing, like, to try that. But I don't know how can be my behavior, my feeling, if it become my daily, habit, like to get out from my home, jump into such kind of car and have the full trust. At the first time it was like, okay, trustful for me, like, but because it's like, as a kid, is
Yeah.
have an amazing experience. But this amazing experience, if go through the time, do you think that will increase the trust or decrease the trust?
This is a very interesting question because I gave a similar version of this talk 2 months ago in Eindhoven, and we had a very interesting discussion with a person that had been doing this for already 5 years, who said that at the beginning there was a novelty effect of this is interesting, and then there was insane panic over how can I trust that the car is good at calculating all of this. And then over the span of the 5 years that she has been driving in the AV, this has gradually but stably increased. So her trust over time, by seeing that the car is reliable, the car is performing, was rising, was not declining. So as the novelty effect wears out, we didn't know if people would get bored of it or not, but she said that she was very, very happy with it, and she could only see how, as time goes by, the car is still very reliable and, is calculating everything as it should. The problem with our field is that we don't have proper longitudinal studies on this. And that's exactly what we would like to do. We would like to be able to follow people throughout on a timeline of 3, 5, 10 years and see how this can change. Right now, we have an anecdotal evidence from people that if you're lucky to have no incidents in an AV and you are using it regularly, your trust only increases in it. But also since you've been, you can say what was your first reaction? Did you have an interface where you could see all of the information, or was it a very minimal one and you just felt like you were in a robot taxi?
All right, perfect. Thank you. So now let's move to hear from the business perspective with Flavia. Around all the hype of AI, and regarding the investment on AI, how it's perceived from the business perspective and VC's perspective. As I learned, the term AI was invented or chosen to this area in order to get fund in the 56 workshop. It was like people were looking for a sexy term in order to get fund from the American government. And during the history, AI had, let's say, spring and winter. Spring, the research is continuous, but the spring in terms of funding and investment. Now we are in this spring of AI. It will continue or not? Let's dive into that with Flavia. Please, the floor is yours.
I would say
Amazing.
it's a warm summer, Hedi, not a spring.
My God, yeah. Well, thank you very much for having me and the invitation. I think I've been very lucky over the past 15 years to work across a number of investment funds, and more recently with academics around AI and robotics. So Karim has spoken directly to me in his presentation. And family offices as well. So it's been quite a journey. I think that AI is the new electricity. So it's made leaps and bounds over the past 5 decades since its nascency, and it's becoming more and more embedded and transforming every single industry. So maybe we're in spring, maybe we're in summer, or maybe it's May, so you can't really determine whether it's spring or summer or somewhere in between. I'm hoping that today I will take all of you on a short journey. I'm mindful of the time, and I will walk you through how did we get here, what are the sort of breakthroughs that got us here, because as an investor, you're not necessarily detached from this type of reality. Where is the capital going? how investor focus has shifted, because I think that's on the lips of a lot of founders nowadays, looking to innovate, looking to spin out of universities, and where we might be heading next in terms of our focus as a sector across Europe, but even more broadly. So let's start with how did we get here? I think whether you're an investor or whether you're a founder, I think you have to position yourself. So we started in 2024. There have been a lot of decades where a lot of things have happened, but very gradually. So this is why we had the season change. And 5 moments in the last decade have really shifted everything that we do and have led to the way we build technology today in this space. The first, it was the generative adversarial networks and allowed machines to create things, images, videos, music. And then we had another major element, the introduction of reinforced learning into mainstream. We had DeepMind doing that. Following this, AlphaGo, they've been acquired by Google, and it changed the game where we had layers upon layers of neural networks that were in a position to analyze infinitely complex data. And then in 2018, we had the transformer architecture, which arrived for everybody. Transparency. Transformers are a foundation behind BERT, GPT. They're a kind of a neural network that makes it possible to train a model on languages in a way that we haven't done before. And then we have moved on into 2020, where OpenAI, still very much a non-for-profit, introduced GPT-3. We had the 175 billion parameters that have been shown to show human-like text generation. And then we're coming today where we're in a position where we saw the explosion and mass adoption of GPT, Claude Bot, Copilot, Gemini, and millions of users within weeks. So something that we have not experienced for a while. Which brings us into an inflection point, dare I say, not only from an investment and how investors should look at this, but technology and maybe humanity. So what has made this possible? What are the building bricks? First, data. We didn't have a lot of data, but now companies like Google, Microsoft have amassed some of the largest data on human activity and behavior to have ever been known. Everything we do is monitored, collected, and has been used to train computers. We also had the law of computing power, lowering the cost, the time to train models. Is no longer impossible for a student in a dorm to do it. Everybody can do it. The cost has lowered so much over the last 20 years. Then we have GPUs, and then now we have CPUs. And most importantly, because of all of this, we have different types of algorithms. I am mindful that we're now back propagation efficiency, transfer learning, reinforcement learning, self-supervised learning. All of these techniques that came within the academia have rolled onto startups and then have rolled onto the world and have made quite a lot of progress possible. And finally, dare I say, we wouldn't be here today if we didn't have open source. And I'm thinking here, TensorFlow, libraries from PyTorch. It would have not been possible if we didn't have startups, researchers, students experiment, improve, share freely. And this is what created this perfect environment. So when we're speaking about AI, I think that we often forget that we need to look at the wider picture, because when we're investing in a much larger larger architecture of what underpins the AI ecosystem. And by this, I mean the three different parts of the supply chain. Yes, AI has a supply chain, and there are substantial challenges at every single point. It starts, of course, with the semiconductors and the chip designer manufacturers, and then we have NVIDIA, Qualcomm, AMD, large corporates, foundries that are sitting mostly in Asia Pacific. We have the integrated device manufacturers, companies like ABB, NG Systems, Eaton, that are very much leading the way, and they're making some of this work possibles. And then we get to the data. And then here we have some of the major cloud providers like AWS, Google, Azure. And on top of this, we build software. So it is on this top of the architecture in all of this legacy that we have foundational models like OpenAI, Anthropic, DeepMind. We have the middleware that enables us to transfer data, to process data, to move it, to then be in a position to make some sort of judgment. And then on top of all of this, the applications, whether they are business or consumer, whether they're applications, they are very much operating within this. And if you are paying attention, we have seen that most of the journey that is on this slide, although not created by myself, unfortunately, it's from hardware to cloud to software. We're heavily dominated by American companies, but for a few exceptions on the devices and chip manufacturers which sit in Asia Pacific. So in this landscape, we are building on something that we cannot control and we are very much dependent on. So when we discuss the investment priorities, sovereignty, and all of those elements for the next wave of AI companies in Europe, I think we have to at least acknowledge that this is what we're building on. So how has the investment community responded? And this is an important topic. I have one word, and that is aggressively. If we look at the 5 decades, the figure is in the trillions, is mostly led by America, by the US. But over the past 3 years, when we had the spring and we went from March to May, we have seen something of an acceleration. So if we take 2024, we see this kind of doubling of investments in the US, Asia, data from Asia. It is to some extent questionable. There are multiple sources the audience can read. There is some disconnect between reality and what is actually happening in some of those jurisdictions. So I think for 2024, some of the best analysts in the world are saying that actually we've invested something like $200 million, maybe 180 billion euro equivalent. So it is in this context that we're seeing an acceleration. There is one thing that we should note. US has invested for 5 decades in infrastructure, research, computing space, and of course, the applications that sit on top of all of that mountain of trillions of dollars of investments and 50 years in the making. Europe is building its foundation. I'm very happy that this week we had an announcement of 10 billion that are coming for gigafactories. So very good news for all of us moving forward. But I think the opportunity is huge. So let's zoom into the priorities and how they've changed. Luckily, I have been through this journey for quite a while. Dare I say, I still celebrate the same birthday. I don't know what happens. So I've broken down into 2 periods just to contrast a little bit about how maybe the appetite has changed, just in case some of the people in the audience maybe are wondering. And if you've been to events then absolutely great. You would have probably seen this over the years, how the dialogue has changed. So from when we were back a few years, 2018, 2020, pretty much every company, every event, every pitching session everywhere, at least in London and some of the European cities I've been to, were more focused on ML platforms, NLP, vertical SaaS, chatbots, maybe some advanced analytics. And there was a lot of emphasis when it comes to accuracy, and the defensibility maybe was through data, maybe was through the robustness of the system, maybe was through the ability to develop slightly better prediction, better output from processing that data. And this is still very much based on US infrastructure. So all of the architecture for all of these systems, very much US dependent. I'm not saying whether the server was in Europe or not, but I'm saying that it was built on vast majority, actually 99.9% on such architecture. So then we're kind of segueing into the last year and this year, and I think everybody going onto the circuit in Europe, at vast majority of the conferences, we're seeing a shift towards agentic AI. So what does it mean? It means systems that are able to make decisions, they're able to take action, they're able to operate autonomously on behalf of their principals. So it can be any type of environment, business environment, industrial environment, healthcare, education. So this is what we're seeing. We're actually, this week, we're seeing hundreds and hundreds of millions of dollars in euro equivalent invested in exactly this type of companies. And the second is multimodal systems. We've seen last week GPT making bounds and leaps, and now we're able to processing images, voice, videos. It has a lot more functionality in the last week. And I think that will become the norm, and it will continue to deliver more and more capability. And of course, AI native pilots, co-pilots, this is really embedded upon a different system, and it helps a specific workflow. We have seen Oracle winning one of the largest contracts in AI, just within the last 7 days, 5 billion to work with a state department in the UK to work on this type of architecture. And then we've seen in France, Mistral AI being able to win a 1.5 billion euro contract with the health system. So these are very, very huge opportunities. And then, of course, we're moving, and Karim, close to my heart, physical AI, the embedded system robotics, and the real-world applications. It has been in vast majority of the conferences. I think we all heard speeches from some of the most important people in our industry. And this is the next big thing that is going to happen. So what has changed in terms of defensibility? It is no longer just the model accuracy, because we already have model, they're fairly good, but I think it's shifting into a point where whoever gets invested, and by all means, I'm open to being challenged, it is about the data, the industrial IP, and the deep domain knowledge, because I don't think we have the bandwidth to invest the tens of billions into one company, but we do have an ability to invest hundreds of millions into companies that are building and they have defensibility through IP, through data, through very deep links and domain knowledge. And this is more about the vertical integration, bringing together models, data, UX, in from a specific domain and wrapping it above all of the infrastructure that exists in the supply chain for AI. So as an investor, you might or might not be aware, if you're in the audience and you are coming from the space, by all means, please comment, share your opinion. I'm interested. But from an investment perspective, you have to look at what happens on the demand side and this is where I think it gets really, really tricky. So on the demand side, we have 82% of all the corporates in the last 12 months starting to think about redesigning workflows. So everything is starting to be not about chatbots, but about the Gen AI to the fabric of how organizations work. And we see this through the type of contracts that are being won in some of the largest companies across Europe. We're thinking hundreds of millions, billions. So these are no longer SaaS enterprise type of contracts. These are completely different ballgame. By all means, vast majority of leading management consultancies have published amazing research and definitely worth reading. Second is the governance. We see a shift, unlike SaaS and all of the other solutions before. It's the CEO, the boards of these large companies are driving the change. They're buying in. It's no longer bottom up, it's top down, which means that this is on the top of the agenda. It's not whether they invest or not, it's just how much and how quickly they're going to deploy it. And this has a repercussion on the skilling. So we see even for the education of AI literacy, an absolute boom if you pay attention. And then if I kind of move forward, we're seeing playbook changes, the approaches to how the return on investment for such exercises is being rolled into those companies. And the most important, governance. I think that we're seeing, because the board is involved in such large decisions of deployment, and they tell us what they need, we're seeing their involvement into how those systems would operate and how the company will achieve its efficiency in the long term. In terms of capacity, you might have seen quite a lot of different types of research. The estimated is that we're going to see about 826 billion from revenue from this type of systems over the next 5 years. Others are saying that, more broadly speaking, economic benefits will be somewhere around $15 trillion equivalent. So we're speaking about the technology that doesn't resemble SaaS enterprise as we were, 5 years ago, mostly speaking about this. This is a completely different game. It's a market that is creating itself, and you no longer have to do estimations. It's real. You have to basically search the announcements for the contracts, which is something that personally I haven't seen. So we're coming towards a journey, and I'm mindful that we have a very limited amount of time. So 1 minute, we're going to go through this. A roadmap of what could be coming next in the 5 years. So we have more modular systems. What does it mean? Easier to adapt, easier to specialize. I think we're seeing a lot of the companies that are winning funding rounds from the top VCs basically advocating for this. We're seeing multimodal, so again, specialized, but becoming more standards across all types of mediums, text, image, video, sound, and beyond. We're seeing energy efficiency, a discussion of improvement of performance at edge on various different types of devices, whether they're industrial or consumer. We're seeing trust layer being implemented, so an ability to audit what is inside the models, an ability to have that transparency. I think it's coming within the next 18 months, in my view, and many other people. And then I think from kind of next year onwards, we're going to see multimodal agents that are able to fit within real workflows, whether that is industrial, the production line of an auto manufacturer in Germany, or whether it is in your high school or university, delivering of educational mandates, or on the hospital floor. I was here in Eastern Europe, and it was absolutely mind-boggling to see the level of technology in some of the top hospitals and operating room, and how even some of the most highly ranked surgeons are starting to use AI for predictive elements or for planning. So I think we're going to see a lot of that into the healthcare and beyond. I am very hopeful that as companies like the ones that we have here today are making progress, we're going to see physical AI models starting to arrive and starting to emerge and starting to be on the factory floors and starting to scratch and being able to retain quicker and quicker and quicker for applications, not just for the very large conglomerates, but for the smaller, medium-sized production facilities. And as we're going to 3-4 years from now, hopefully we're going to see the human AI collaborations in the hospital, and not just specialized, but maybe role specific rather than task or workflow specific, where doctors, teachers, workers, even clinicians are working in a more general way with the technology that is around them. So a way of improving efficiency in a way that we haven't seen before. And I'm convinced, I don't know about AGI. I don't claim to have the knowledge or the ability to say whether we are going to get there or not, or what it would take. I will leave my colleagues to do justice. But I do feel that we're going to head within the years of adaptive platforms that I can use in a variety of roles, whether I'm a marketing professional or whether I'm a finance professional within the same company. I can use the same system to help me achieve a specific level of efficiency. So I am very optimistic, and I think that investment community, it is looking at this picture and it is investing in companies that are painting the various different avenues in which Europe can continue to build and lead. Thank you.
Thank you, Flavia, for this nice presentation, and also show like other perspective regarding the investment and the adoption of AI. And I think the next section of this webinar will also like dive on that. So I'm happy to give the floor to Oliver Haas, who is the Managing Director of Innovation Network for Advanced Materials, who will moderate the panel today. We are running a bit over time, so maybe I will ask, if possible, for participants to stay a bit more, but also will ask Oliver to be, let's say, to have an unbalanced panel by giving the words maybe for our other two guests in the panel, Ricardo Sanz and Luis. So please, Oliver, take over and manage from your side the panel. Thank you very much.
Thank you very much, Hedi. It's a pleasure to be here with you today and moderate this panel, which at first glance seems to be quite remote from what is my day-to-day job, i.e. managing the Innovation Network for Advanced Materials. But no, it isn't, because materials are what keeps computers going, and innovation in materials, of course, makes faster, better, and more efficient computers, also on the energy side of things. And besides that, we see, as in many other labs, also the trend of self-driven labs, AI-steered / digitalized labs, which then ideally creates a virtuous circle with new materials being created by AI that will power even more powerful chips. But that's just, dreaming into the future. But anyways, super happy to have you here. And we have two panelists, Flavia and Anna, that have been presenting already. So I would, as Hedi also suggested, ask the other two, Luis and Karls, quickly to introduce themselves, and then we dive into a couple of questions around the topics that we've been discussing today.
Hello, good afternoon. I'm Ricardo Sanz from Madrid. I'm professor in automatic control at the Technical University of Madrid. And I am the coordinator of two European projects. One is Meratur in this topic of awareness, and the other one is CoreSense in AI in robotics, that is also very related to awareness.
Great, thank you very much. And let's keep it relatively open. Whoever thinks they can contribute and want to contribute to a question, please go and grab it. So the first one is basically tying what we've been discussing about for most part of the webinar today, i.e. awareness and consciousness, back into the discussion. So what exactly is the relationship between awareness and consciousness in AI systems? How do these two concepts relate to each other?
Oh, Lisa, who are you asking?
Please feel free if you
Anyone.
Anyone, exactly.
Well, as everybody knows here, consciousness and awareness are less than well-defined topics. Regarding humans, there is no clear understanding of what consciousness is or what awareness is. And when you translate that to machines, we need to do an effort into simplifying things, because at the end you need to be precise when you want to be creating programs for machines. So concerning awareness in machines, as Carlos saw before, is related to the exploitation of information in a meaningful sense, basically. And the question of sentience, the question of experience, the question of qualia in machines is just not addressed at all, because it is not even understood in the case of biological systems. So phenomenology in machines is not existent today, but awareness in the sense of access consciousness, it is. So phenomenological consciousness not, access consciousness yes. But this is not a new topic. This is a classical topic in AI and robotics from many, many years ago, and is nothing new, in fact.
Yeah. When it comes then to the question of ethics, and I remember actually moderating a panel a couple of years ago, actually 7 or 8 years ago, where we discussed the question of ethics in relation to AI, and in particular in the then quite prevalent topic of reproduction of biases that you find in data sets. How do you relate that to the topic, and how do you think we can basically better address such, let's say, problematic data sets? Ricardo, you can.
Shall I take it? Or,
oh, yeah,
or
sure.
okay, no, but I can go after Ricardo. So.
Yeah, no, you can go.
But I mean, we already spoke a bit, in a way, all of us during this webinar, and definitely an issue is that right now, a lot of the modern AI solutions, so from large language models to so on, really have this brute force approach. And as opposed to previously, when you do want to train an AI solution, so a machine learning solution to something, you do have very selected data. Right now, you can have a lot more training data, so you do have much better systems in our sense. Both approaches have a problem. The earlier approach was the problem that you can perpetuate biases by having data sets that are very, very narrow, that are not representative of society at large, that themselves carry the biases. But this is not solved right now. So you have to still check all of the data that we use for training in order not to carry on these biases with us. And right now, you are also infringing on people's personal data. We have had already several instances where we would like to do something on AI generating a voice, for instance, or something. And a lot of the solutions that we're encountering with the product owners say, yeah, but we will be saving all of this data, and they are sensitive conversations maybe, but we need it for training it. And we don't really have a system in place because perhaps we are not really EU-based, so we don't have to abide by GDPR law so well. And so that is such a big problem right now. And we are absolutely still at a risk to carry on biases if we don't have a better say in how the data is used and how it's regulated. So it's not really maybe linking this to the big concept of awareness, but I can address it from the ethical side that right now, maybe having, so I'm not going to give as strong no as Karim was saying. So perhaps maybe with some hybrid solution with large language models, there might be potential for using this towards AGI. I'm not saying it outright no, also because I'm not so specifically into that field right now. But from the ethical side of things, there has to be a better way of going through the data that we use for training and trying to involve the stakeholders in the process right now. So I can say that one, and then if someone else would like to relate it more to awareness, I can leave the floor.
I think, if I may, I think we need to, like with other values or topics, what the only approach that to me makes sense is that we should make machines aware of these facts, in particular to be aware of the bias of data. So the thing is we will never have something that will be perfect, because we will disagree actually on how should be the data be filtered or adapted. So the question is that if we want to provide agents, well, by the way, I hate this name agentic AI. I mean, it's horrible. I mean, we have been working on autonomous agents for decades and multi-agent systems, and now we have this new word, agentic AI, that is quite recent, that I really dislike. But in a sense, the question comes when we want to provide autonomy to AI systems so that they take decisions, because we want the agency of these AIs to be respectful to what we want them to do. And this is the key issue here. I mean, how are we going to tell or to embed these AI systems with the capacity of experiencing the world, so that embedded with the social values that we want them to preserve, they can analyze through that experiencing the world what are the right decisions in every moment. So perceiving the world and deciding what is the best act of course of action in order to make their decisions. So I think the question is, so the notion for awareness to me is all, I agree with Ricardo. I mean, we are talking about functional awareness. So it's not phenomenological awareness. We're not interested in phenomenological awareness at all. I mean, but the question is, we need these systems to know what is around them, to be able to take decisions that respect our values, because we want them to be ethical. So we need functional awareness, and that could fix things like the data bias and other problems. I mean, that's, I don't know if I was minimally clear, but to me, that's the main issue.
As I mentioned in my speech, self-awareness is something you need in order to model your world and understand your world. So apparently that's that would be this is a necessary condition for a robot to function in the real world. In terms of context, there's a Arabic proverb, El insan mushtaq min al-uns, which means that the word for human is derived from the word from company. So I believe this speculation, but the consciousness is related to social interaction, and social interaction also needs modeling. So when the system is able to model other humans, it will sort of be more conscious, more aware of itself in the social interaction with humans. So that's that could be part of the conscious part of AI. So modeling other human beings.
Great. That was
May I say something
sure, please.
regarding this last comment and some of the comments concerning ethics and context and this stuff? I think that we are dealing with a big problem. That is the problem of thinking of those machines as if they were human. They are not. And trying to make them human is a big error, basically, for several reasons. One of the reasons is that we do not understand humans perfectly. So we cannot match human capability to machines because we don't understand humans. That is one fact. The second fact is that we don't have the information and the data. The bias that we are talking about is because of that. We don't have strong and rigorous data about human behavior. And the bias that we are inducing is because the information of the system that we try to copy is wrong, basically. And this is just bad engineering. It's nothing more than that. So the question of ethics in machines is just bad engineering and lack of a specification of requirements. If we want the machine don't kill any children, we can specify that clearly. But the problem is, what is a children? the concepts that we are using continuously to talk about this are human concepts. And we need to avoid that. We need to use machine concepts. Otherwise, we are all the time going around talking about things that do not match the machines that we are dealing with. And that is the problem. We cannot use human terms for talking about the machines. We should use machine terms. If we want to put awareness into the machines, we need to define awareness for machines, as Carlos was describing before. Otherwise, we are just going around and comparing things with humans, and that is wrong. That is an error that we are committing all the time.
Yeah, but Ricardo, we need something in that direction, because we are heading, I think it has appeared in a number of the presentations, we are heading towards hybrid societies. And this is a fact. I mean, we will be living in societies where we will be interacting with robots and with agents, software agents, in order to do our daily tasks. And we need meaningful interactions there. And those interactions means that somehow these robots and these machines need to talk our concepts, because otherwise we are not going to be able to.
But Carlos, maybe not the case. Let me say something. Maybe not the case that we humans need to learn machine concepts.
No, we are not interested in machines.
But approaching machines to humans is a weak approach, because the human concepts are weak. And we need to elaborate systemic concepts that are neutral, that are universal, that apply to machines and to humans at the same time. So we can find a meta language where we can have meta concepts that are valid for both. And that is the problem at the end.
Yeah, but we need to tell machines, or machines have to learn by experience, that if it is an autonomous driving car, I mean, it's not good to kill another person, but if you kill a dog, it's not as bad as killing a person. So we need to make them aware of some of our concepts, because we want to meaningfully interact with them. I'm not saying that they will, but they at least will need to have a representation of these concepts in order to be useful to them.
You know that those concepts are flexible concepts all the time.
Yes, yes.
Just some months ago, I was in a conference on ethics of AI, and most of the people there were military people from the US. So having a robot that is a killer robot has an ethical concern that is very different from an autonomous car.
Sure.
So the question of what is relevant, ethically relevant for such a machine is very different. So we cannot just learn from human data. We shall be explicit about what it means, friend or foe, and be precise about that, because otherwise we will not be able to engineer machines that are solid and predictable.
Yeah. But in both situations,
it's a very interesting discussion, and we have this discussion in our company as well. We can build a superintelligence that's an alien intelligence, or we can build a superintelligence that's a human-like intelligence. And this is a really big difference between those two design principles. A human-like intelligence is possible for us to understand. It has communication skills that are adapted for humans. And I think it's important to keep that direction when we design superintelligence, and don't deviate too much for it. If we do, we'll end up in big trouble. So yeah, that was my comment. Yeah.
No, I think I like the approach of Ricardo of saying, look, we're talking about machines. They might be super intelligent, they might be super capable of doing all kinds of things, but still they're machines. So we have to address them as machines, because I mean, as humans, we tend to have the tendency to humanize all kinds of things, not only machines, also our pets and whatever. So that in itself, I think, is a very good mind switch to look at the problems that we have.
Another comment also, with artificial general intelligence, or intelligence that's able to is efficient in modeling its world, might be very efficient actually in modeling humans and human behavior, and might have a larger understanding about what the human is and what it's not, due to its modeling capabilities. And that means that an AGI actually can help us answer the question about what it is being human and what it is being a machine, and also guide us towards what the consciousness might be about. And the AGI might itself be the answer, actually.
No, indeed.
Yes.
That could be an interesting solution.
Just a comment about AGI. If you look at the definition of what AGI is, most definitions say it is a human-like AI. And that is not AGI at all. Artificial general intelligence is general, is not human, it's something different. So we are using bad definitions for this concept. So AGI is not mimicking human at all. If they want to mimic humans, they need to create another term for it. That could be artificial human-like intelligence, for example, because it is not general at all, because humans are not the top of the intelligence. This is something that is totally anthropocentric, and this is a mistake. We are not the top of the thinking process, in a sense. There are machines that are much better than we are in certain tasks. That depends on the task. Depends on the task and the capability.
Yeah, I partly agree. I would say that humans, as a collectively, represent the general intelligence. A single human may not be, but so in that context, artificial general intelligence is still human-like intelligence, but on a collective scale.
I think Flavia is raising hand, and
Exactly.
also I remind Oliver that
We have to
15 minutes
yes.
over.
Oh, bless.
No, but I'm super happy to see so many people stay even after 5. I'm skipping a call myself because the super interesting discussion. Then last word to Flavia, please, and could you also please.
I just think we've discussed about something that at this moment in time nobody can tell us, AGI, or when we're going to have machines that are conscious, they're able to interpret and interact with the environment. I think maybe we should look at the next 5 years or maybe even 10 as context in the sense of a setting such as agriculture, industrial setting like a warehouse, and awareness is specific to that environment. And I think we don't have that now. So the machine doesn't know it's in a warehouse. It doesn't know what the warehouse looks like. And I think that that's what we need to do. Maybe once we have that awareness from all of these specific places, we can then have a higher layer of abstraction that can be then more general. But I think that right now we don't know. The robot doesn't even know what other room is in the hospital or what other room is in that warehouse. So I think we're still early in the journey, and I think maybe it has to be contextual and sector specific for a period until we can even see the how AGI could be achieved at all.
I fully agree, Flavia. And actually, in our definition, we started exactly with that. I mean, a system is aware of X in a context C. So it is a context that you have to define first, and then define awareness in that context. So I think I'm in full agreement with.
Carlos, may I ask you a question?
Sure, yeah.
What is a context?
But you can define it as.
Again.
Yeah, I mean, the context you could define in engineering terms, an ontology describing what is in your world, in a sense. You could define it that way.
A framework, a conceptual framework.
A conceptual framework, yes.
Okay.
Something that explains the limits of what you can do and cannot do. What you can perceive or you cannot perceive, yes.
Yeah, in terms of robotics, it's the sensor input and the motor output, so the actuators you have. That's the context.
Yeah. But I agree with Flavia. I mean, this is far from general intelligence, which means solving problems across all domains and all tasks. I mean, this is extremely ambitious, and we are very far from that. That's my opinion. I mean, I disagree with Karim in that we can get there very soon, I'm afraid, but I think we are very far from AGI at this point.
Actually, it's like a baby. If you have if you have a baby, it can grow up to an adult, intelligent person. So if you have the conditions right from the beginning, the development will accelerate towards super intelligence. Actually.
Yeah, but we come with a pre-programmed brain.
I
result of the evolution.
I hate killing off discussions, but I think we do have to come to a close at a certain point of view in time. I'm super sorry about that, but it's already almost 20 past. But this shows that there's a lot to talk about, and there are many discussions to be led. So Hedi, I think you know, the upcoming
thank you,
Oliver.
I think we abused our attendees, and I will ask for 2 more minutes to answer online survey. So Jessica, if you can go slowly, share the link and allow people to interact. Your input is very important because this helps us also to build the priorities in terms also of next programs and so on. So please answer the survey. So I give the floor to Jessica, and in parallel, I would like to thank our speakers, attendees, and so on. And so please share the screen and go ahead, Jessica.
Yes, thank you, Hedi. Thanks a lot for your patience to stay in this for this few minutes for this our really brief survey. So please tell me if you can see my screen. Should be in full size mode now.
Yes.
So I will
Jessica.
ask you just to reply to really some questions regarding the webinar, the content of the webinar, so the AI, and then also regarding the webinar organization. So you can use the QR code here, or you can insert the code you can see here in menti.com. And I will now, I will go fast on the questions so we can reply to all of them. So first question, so the first part is the knowledge validation. So what are the main gaps to develop and adopt those AI capabilities? So please reply to one of these options.
Can you get back to the, I couldn't.
You can use the code app. You can use the code. It's always in the at the app of the slide. So yeah. In the meanwhile, I just closed the door. Sorry. Okay,
Yeah,
thanks
Carla,
a lot.
just add in menti.com 11074967.
Yes, you can use the code that is up on every slide. So you can usually use it really quickly the code, and you can enter the Mentimeter survey. So thanks a lot. I will go to the next one. So what is the most risky impact of such capable AI from your perspective? Also here you can find 4 questions, and please choose the one most suitable or according to your knowledge.
Oh, we can choose only one. Okay.
Yeah, yes. Of course, if you would like to comment or to send us an email with some other comment, please do so, because they are anonymous query replies. So if you would like to add any comment, you are invited to do so via email. We can address them. Okay, thanks a lot. I will go to the next one. What is the main opportunity of AI innovation from your perspective? So also here you can find 4 questions, 4 options, sorry. And at the end of this survey, you will find an open question. So there you can also reply with some comments that you think about this survey. And of course, if you would like to comment something about the organization, we're really glad to read them. Okay, thanks a lot. We'll go to the next one. What is your recommendation for the future innovation in AI? I see really fast to reply, so thanks a lot.
Everything. We want everything.
Okay, yes. I'm going to the next one. Thanks a lot. So now we go to the, let's say, the organization part of this webinar. So I was satisfied with the content presented during the webinar, the content that was presented by your speakers that were attending today, and which we really thanks Thanks a lot. I will go to the next one. They are really quick questions. So, has the webinar helped increasing your knowledge regarding the topic of AI and awareness, of course? Thanks a lot. So we go to the next and last questions, if I'm not mistaken. So are you satisfied with the overall webinar organization? So everything that was behind and before the organization of this webinar. So the invitation and so on. Thanks a lot. And then I think now we have the open question. So, no, sorry. Would you like to stay informed about our future communities, AC communities activities? So other webinars and other activities. Thanks a lot also for that. And then now we should have the question. Yes, the open question. So if you would like to add any comments or feedback you have about this webinar, please also send an email to us if you have some comments or suggestion or anything else. Thanks a lot.
Thank you, Jessica, and thank you for all of you, speakers, attendees. So the recording will be shared soon, and it will be online. So thank you very much, and stay tuned. Other webinars are coming. So thank you very much. Bye-bye.
Thank you very
Bye.
much.
Thank
Bye.
you.
Bye-bye.
Bye, guys.